Hello everyone, welcome to this video, and in this video we're going to do adding and subtracting rational algebraic expressions. In adding and subtracting rational algebraic expression, there are two cases that you want to identify first before doing the operation. The first one is what we call adding now the like denominators. So when you say like denominators, this is much easier. In structure, we could say that if you have na A over C plus B over C, now as you can see, the answer is easily just adding the both numerators, which is A and B, and then the denominator would be C. Now, it goes with it also the same, the concept is the same if you're subtracting. For example, if you have now A over C minus B over C, your answer would be subtracting A to B. Or rather like you subtract B to A, and then that will be over C. Now that's now the first case when you look at. Now, one of the complex one, why we started with multiplication and division when you're working with this one, is what we call the unlike denominators. The unlike denominators, there are a lot of things that you need to do before you go with addition and subtraction. So for example, the first case is adding. If you have now A over B plus C over D, what you're gonna do is like you're going to work on with a lot of multiplication. What I call this one is the butterfly method. Why butterfly method? So let me just put now a color with that. So that's the first thing that you multiply. Second is A and D, and then this one. So as you can see, it's just like a butterfly. However, in the context of multiplying that, so you have now B over B times D, then you have now A and D plus BC. That also it's also the same when it comes to subtraction. Just B over C over D. Oops. Let me just erase that because we're working with subtraction. So minus. So we have now AB minus BC all over BD. So that's now the structure in adding and subtracting rational algebraic expression. So let's answer this one. So for example, I have here 6m minus 3 over 2m plus 1 plus 2m plus 7 over 2m plus 1. As you can see, they're both the same. So it's much easier for us to add. So you have now 2m plus 1 because they're just the same. Then you add now 6m minus 3 plus 2m plus 7. Now, getting now what's like term. So the like term here is this one and this one. So 6m plus 2m. So let me just expedite that. So you have now 8m. And then this one, negative 3 plus 1. So you have now 4 over 2m plus 1. However, you better check now your terms if they have common factors. So these two have common factors. So you have now 2m plus 1 over 2m. So you can have that deducted. So the answer is now 4. Okay. Now let's have now another example. Now the other example is that I think I had, it doesn't have put this one, should have one here. Okay. So working with this one. So when you analyze this one, the denominator is almost the same. Why almost the same? As you can see, this is 1 minus 2x and this 2x plus 1, right? Am I right? No, I believe the example, sorry. So this should be, that's why it's something like I forgot. So this should be minus 1 rather. Okay, as you can see, they are almost the same now, right? So if they're almost the same, you check now one of them, you can change them into a negative sign. So as you can see, I can change this one to negative sign. So what will I do is that I copy this one, 5x squared over 2x minus 1. I thought that there's no 1 there, but it turns out like addition. So I have here x squared plus 1, and then I'll factor now negative 1. So I'll have now 2x minus 1. So they're almost the same, and then I'm going to bring up negative 1 there. So I have now 5x over 2x minus 1 plus negative 1 times x squared plus 1. Then I have now 2x minus 1 here. So working with that, so I have now for final setup, I have now plus negative x squared minus 1 all over 2x minus 1. Make sense? So working with that, I have now negative x squared plus 5x minus 1. over 2x minus 1. I believe this is now the final answer. Right? Okay, I think we're good with that. So let's have another one. So this is now a unlike denominator. So what will happen now? Let's do the butterfly. So 7 times 3. So I'll put it 7 times 3 here. Then 3 times 3. Then 7 plus 1. 7 times 1 rather. So I have it there. So I have now 9 plus 7 over 21. So I have now 16 over 21. What if we're working with that as subtraction? So 3 over 7 minus 1/3. So once again, the same. It will have now 21, 9 minus 7. So that's the case. You have now 2 over 21. So that is now the case if you have that. So let's have another one. Okay, another one is that 5 over 8m squared n to the 4th plus 2 over 6m cubed n. Technically, when you were in elementary or in your younger working with fraction, you get with the LCM, right? Or LCD rather, LCD. So we can list down this one. So 8m squared and n to the 4th. So we can have it here like 2 times 2 times 2. And then I have now 2m. And then I have 4n, right? 1, 2, 3, and 4. Now, for this one, it's like 6m cubed n. So I have now 2 times 3 times 3m's, right? Then 1n. Now, we can now find out what's common. Let me just have a mark of what's common. So it's much easier. So you have this one. And then we have this 1, 2, and then 1n. So we're now looking now for LCM or LCD. Is common denominator, LCD. Write first what's common, which is 2 times m times m times n. And then what is left? 4 times n cubed times 3 times m. Now, multiplying that 4 times 2, that would be times 3. 8 times 3, that would be 24. Then I have m squared here times n cubed times m. Right? So simplifying that, you have now 24 m cubed n to the 4th. Right? Now, what you're gonna do now, we're working with this one. Let me just a little bit make it bigger. Zooming it. So you have now common denominator, right? So 24 m cubed n to the 4th. So that's that. So you divide that. So 24 m cubed n to the 4th divided by 8m squared n to the 4th. So what would be the answer? 24 divided by 8. I believe that is 3. And then m squared m. And then this is now the thing that you multiply. So 3m times 5 for the denominator. Then plus, you have now 24m cubed n to the 4th divided by 6m cubed n. So what do we have now? 24, that would be 4. Cancel now 3. So you have now n cubed. So you have now 4n cubed. Oops, let me just erase that. N cubed times 2. So working with that, we have there 15m plus 8n cubed over 24m cubed n to the 4th. And this is now the final answer. So there are no commonalities between them, and that's good. So let's have this one. There's another one, another approach. As you can see, we have now x squared minus 25. We can now get the factors of that as x plus 5 and then x minus 5, right? And then x minus 5 is just simply x minus 5. Now we can now put now what's common to them. So we can have now LCD. What is common is x minus 5. And then multiply that to x plus 5. So as you can see now, you divide now, so we can have it here like x squared minus 25, or this is what we call x squared minus 25. x squared minus 25. So we have now 4x times 1. Minus, you have your 5, and then x minus 5 times x plus 5, which is the LCD, divided by this denominator, which is x plus 5. What is left now is x minus 5. So we can now write that this one as x minus 5 and then x plus 5. Then we have here now the product. So we have now 4x minus 5x plus 25. So we have here x minus 5 and then x plus 5. So what's left now is negative x plus 25 over x minus 5, then x plus 5. And this is now the final answer. It is quite a long video. However, there are a lot of cases when doing adding and subtracting rational algebraic expression. I hope you learned something with this video and have a great day, everyone.